Question number 11. The driver of a car applies two parallel forces to a steering wheel. Okay, there is one force acting like this, one force acting like this. Okay, each force has a magnitude of 15 Newton and acts in the direction shown. The steering wheel has a diameter of 0.4 meter. This diameter is 0.4 meter. Okay, what is the torque exerted on the steering wheel? How do you calculate the torque? Torque is nothing but if you have a rod, for example, like this over here, and you apply a force like this over here. If you apply a force like this over here, then this force multiplied by the perpendicular distance with respect to pivot, which is making it to rotate like this. This is your torque. Now, based on this, if you look at this, there is no perpendicular force acting here, but there is a force that is acting obliquely in this direction. So, what you should do? Let us now consider what is the perpendicular component of this force, which means first let us resolve this force into two parts. One along this direction, which will be F cos 65, and along this direction, it is F sin 65. Okay, and similarly, this one, see, this is 15 F over here, and this F sin 65 downwards, and along this direction it should be F cos 65 over here. Okay, now what is that we need? We need this force multiplied by the perpendicular distance, which means what should I do with this force? This force and this force I am not going to consider here, right? Because the torque does not act due to this one, right? If you have an object like this, and if you apply a force like this, if you pull it like this and you pull it like this, then what happens? Will there be a rotation? There will be no rotation. So when will there be a rotation? Only when you apply a force here, so this will start rotating like this, right? And when you apply a force here, this will now start rotating like this. So you are able to see a rotation like this over here, right? So thus you see these two forces are now going to act. So the torque produced by this force is nothing but, let us say, tau 1, which is equal to F sin 65 multiplied by the pivot is here, right? Because you are going to rotate it like this. So therefore, this is your R into R. Okay, and this due to this one would be tau 2 is equal to F sin 65 multiplied by R. Now you can ask me, so what should I do next? Should I add or subtract? Okay, so towards it, now to understand the direction of the torque. Now if this is the force acting here, now the torque here would be perpendicular to this plane, right? So perpendicular to this plane, so the torque is now acting outward to me. Now due to the downward force over here, the force is acting downward, the torque once again is acting outward to me. So therefore, I should add up both the torques. Thus the total torque tau is equal to tau 1 plus tau 2, which is equal to 2F sin 65 multiplied by R. Now what is this value? Let us substitute all the values. 2 into 15 into sin 65 multiplied by, what is the radius? Radius is 0.2. 0.2. Now let us calculate what is that value here. So which will come out to be 2 into 15 into sine of 65. Okay, I don't think multiplied by 0.2. First I will do it, which is 6 over here. So this should be 6 sine 65. Let me calculate what is sine 65 first, so that I can get it correctly. 65 I will put, and then I will go to trigonometry here. Pull this a little bit over here. Yes, 65 sine of the 65 would be 0.906. This multiplied by 6. No, wait. Just a minute. Let me do it once again. 65 I will take. Then I go to trigonometry. Click on sine 65. Then this multiplied by 6. There is 6 here. Multiplied by 6 will give rise to 5.43. So the answer should be 5.4 Newton meter. Answer is D.